two things, two places, and giving a common result is addition. It is like joining. It is like, for example, I say there is 1 and I say plus 1, it becomes 2. But why does 1 plus 1 have to be 2? Because when the need arose in our past that two things were there and they had to be clubbed together, well, it was not convenient to write like if I have five bananas or five apples, I would just say I have one, 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 one. Well, it doesn't look good. So somebody came up with the idea that we would just add one number to itself and give it a new number, right? And so 1 plus 1 was assumed, okay, when 1 is added to 1, we'll have a number that we'll call 2. So this is how 2 came into existence. And similarly, it was that when 1 plus 1 plus 1 would be added, it would become 3. Well, earlier the numbers were not so much, and the calculations did not go any further than hundreds. So we find the Roman numerals, right? The Roman numerals. So you find there as 1, 2, 3, 4, 5, 6, 7, 8, and 9, then 10, and so forth. So when you see this kind of a number series, you actually understand here that okay, this number that is being used must be used primitively, because all you have to do here is a lot of marks, straight marks, and some curves, and that just goes on. But it is not that much developed. Well, that it is. So as passed, the calculations, the knowledge of people increased a lot, and due to that, the new numbers came into fore. New numbers had a new representation like 1, 2, 3, 4, 5, and 6, 7, 8, 9, and 10. So we here have the Roman numerals as well as the modern numbers, and we can easily find some differences that are really effective. One of these is that the new modern system is easier on the eyes because all the characters are easily distinguishable as compared to the Roman numerals, which were not. And the ease is further explained in an example. Like you have to write 21, right? It's 20 and 1, and you write the 21 like this. So if you have to write like 100, here in the Roman numerals will be x 50, and like I have like 55, and this is right here. So it's not just about the marks, you also understand how easy it is upon the eyes, upon your hands, to use the modern system. So we can clearly find this distinguishable. This very example of Roman numerals and the modern system is an example of how things become better with time, with need arising regularly, which entails a change into what is being done, and we find newer and better techniques. But this is not what this class is meant for. This class is upon what is addition, and addition is basic joining. When I write 1 plus 1 is equal to 2, what I have made is that I have made my life easier by writing a single number instead of two numbers, a single number instead of five numbers, a single number instead of 10 numbers. So this is representation, that like 1 plus 1 I write is 2, is a 2 is a representation of 1 plus 1, or it might be individual when you say, but on a subtle level it is a representation of joining of two units which were fundamental. What I mean fundamental is, when I say fundamental, is that you do not need to go, or you yes, you do not need to go generally beyond it. Like, you have one, well, you also have the fractions, you also have fractions represented as decimals, rational and irrational numbers. But when you come to addition, perhaps uh, you would want to take one as fundamental, because in general sense, in most of the cases, you'll not need to go beyond that, except for a 1 point decimal. You generally won't go as kids. So I'm just wiping out the slide and I'm making a new slide. uh, yes, yes. So addition becomes, again, we have learned that addition is nothing but joining. So what is addition? Addition is nothing but joining, right? That's what addition is. Now let us discuss an example of addition here. Example, I write this number and I get this result. So what I have done here is that I have added 5 to 10 and given the result as 15. So what has really happened inside? Let us give it a look and see. Now 5 plus 10 is equal to 15. So how did it happen? Well, I had to know that 5 actually meant this and 10 actually meant this, and so what I have done is that I have taken this and joined with it this, and then placed them together, and this becomes the result. So, in order to understand addition and to know the result, what I have to do, I have to take this representation, this representational number, and sorry, I just take this one. This is my representational number, and I know that this representation of 5 actually means 5 figures like this, and this representation of 10 actually is these 10 figures. And what I do is I count them and I place them together and I write this representation here. So this is basically what is happening in addition at a very subtle level, that you're taking two different representations which you call numbers, and you figure it out in your mind that okay, these numbers are these marks, and then